So welcome to Dynamic Coaching Center. So this is yet another video, and this is going to be a new series where we are going to start with some of the competitive exam question papers where how far engineering mathematics have been asked so far, and we are going to start with the GATE question papers. And this question happened in the year 1993, and this is very important topic as I'm going to start with the matrix part first. So as far as matrix topic is considered, you will be generally asked with rank of matrix, and then you will be asked with eigenvalues and eigenvectors. So eigenvalues and vectors. So these are the generalized questions, and a few of the properties of eigenvalues, eigenvectors, and matrix could also be asked as a question. And one more thing is about the solution part, whether it is a unique solution or trivial solution, singular solution. So those kind of questions can also be asked. So here's the first question, which was asked in the year 1993. The eigenvector or vectors of the matrix. So given is a square matrix, and you can clearly see that first row, second row, and third row, right? And first column, second column, third column. So given is a square matrix, 3 into 3, 3 rows and 3 columns. And everything is 0 except this entry, which is alpha, and they clearly said that alpha is not equal to 0 is r, because they have asked for eigenvector or vectors, so they have used is or r. Option A, it is 0 comma 0 comma alpha. Option B, it is alpha comma 0 comma 0. Option C, it is 0 comma 0 comma 1, and option D, it is 0 comma alpha comma 0, right? So it's pretty much simple that once if you are able to use certain properties of the matrix, then you'll be able to sort out this question in a very simple manner. So let's get into the solution. See, this was the given matrix to you, so let us take that matrix to be a matrix, and by using the property of the matrix, the given matrix is a upper triangular matrix. So what is upper triangular matrix? You know that this is the leading diagonal, right? And if the elements below the leading diagonal is actually 0, then that is called as upper triangularization, right? Upper triangular matrix. So the meaning of upper triangular matrix is nothing but if the elements below the leading diagonal elements are 0, then it is going to be upper triangular matrix. Yes, of course, below the leading diagonal we can see 0, 0, and 0, so which means clearly it is an upper triangular matrix. If it is an upper triangular matrix, therefore the diagonal elements of the A matrix are the eigenvalues of the given matrix. So what are all the diagonal values, which is 0, 0, and 0? So I can say that usually the eigenvalues will be represented by the symbol lambda. So I can say that it is 0, 0, and 0. Now we need to find out the eigenvectors, right? So we know the characteristic equation, which is A minus lambda I multiplied by x equal to 0. So this is the characteristic equation multiplied by the unknown x, which should be equated to 0. It is the procedure to find out the eigenvector. Now we know the A matrix which has been given in the question, right? So which was found to be 0 everywhere, and except in the first row we have one entry in alpha, right? Now what you need to find out is A minus lambda I, and I is identity matrix, which you know that it is uh, 0 everywhere, 1 0 0 0 1 0 and 0 0 1, right? Now you need to find out lambda I, which means I have to multiply this identity matrix by lambda. So I'll be getting 3 lambdas exactly in the diagonal part. Now I have to subtract these two matrix, which is nothing but your A minus lambda I. So which is very simple. What you're going to do is after finding or taking out your matrix, just take the leading diagonal elements and then try to substitute this minus lambda alone, so that you will be able to get this A minus lambda I. So you can see here 0 minus lambda, 0 minus lambda, 0 minus lambda in the leading diagonal, and everywhere the same elements what you have found out in the A matrix, right? And instead of this x, we can go for x1, x2, x3, which is equal to, instead of the 0, you can just put in the matrix format as 0, 0, and 0. Okay, now you know that you have to substitute the eigenvalue, and you know that the eigenvalues are 0. All the three eigenvalues are 0. So let us substitute lambda equal to 0. So if you try to substitute lambda equal to 0 over these three places, you'll be again getting the reduced form of the matrix like this, multiplied by x1, x2, x3 equal to 0, 0, 0, right? Now if you try to multiply this row with this column, so matrix multiplication is like this, row into column. So it would be 0x1 plus 0x2 plus alpha x3 should be equal to this answer, right? So which is actually equal to 0. So I can say that alpha x3 is actually equal to 0, which means I can say that my x3 value is actually equal to 0. But clearly mentioned that your alpha is not equal to 0 in the question, right? So we have found out that the x3 answer, the eigenvector answer is actually equal to 0. So therefore any non-zero vector with x3 component as 0 is a eigenvector, right? Hence in the given option, if you just refer to the question, so option B and D are actually found to be correct, right? So alpha 0, 0 or 0 alpha 0, because you know that the third eigenvector should be actually equal to 0. So two possibilities are there. Both options B as well as D is actually found to be correct. So hope you might have understood this question, and this would have given you a slight insight of how the question's been asked in the GATE question papers. So let's just move on to the next question. So here is the next question. This question was asked in the year 1993, and don't worry, we'll be just doing the problems which has been asked so far in the past question papers of GATE from all the departments, so that it will be useful for all the viewers. So if A matrix has been represented like this, uh, the matrix A power 4 is what they're actually asking as a question, and that has to be calculated with the use of Cayley-Hamilton theorem mentioned in the question, right? So we know that generally if you have say a square matrix, and if you are going to find out higher power of the matrix, then definitely we will be using Cayley-Hamilton theorem, and they themselves have given in the question also try to use the Cayley-Hamilton theorem, right? Okay, so this was the given matrix, right? Let's check whether it is upper triangular or not. So this is the first element of your leading diagonal, second element, third element, and this is the fourth element, right? So this is the leading diagonal, and yes, exactly below the leading diagonal all the entries are found to be 0. So hence it is upper triangular. So since it is upper triangular, we can say that uh, the eigenvalues of the upper triangular matrix are only the diagonal values, right? So I can say that the eigenvalues are lambda 1 equal to 1, lambda 2 is equal to minus 1, lambda 3 is equal to I, and lambda 4 equal to minus I, right? So these are all the four eigenvalues which you can expect here, and this is clearly a square matrix. Four rows have been present and four columns have been present here, so it is a 4 cross 4 matrix, right? Okay, so after using the property that since it is an upper triangular matrix, all the diagonal elements forms the eigenvalues, and now these are all the eigenvalues, right? 1, minus 1, I, and minus I. Now let us find out the characteristic equation, right? Because according to Cayley-Hamilton theorem, every square matrix satisfies its own characteristic equation, right? So what we'll do is we can form the characteristic equation using this eigenvalues, which is a very simple manner. So lambda minus 1, right? So I'm going to bring this it over here, and similarly lambda plus 1, and similarly lambda minus I, and similarly lambda plus I, right, should be equated to 0. Remember here, so you have four eigenvalues which are nothing but the elements found in the leading diagonal. So bring this 1 over here. So it will become lambda minus 1. Similarly, minus 1 to the other side, it will be lambda plus 1. And bring all the entries to the other side and then equate it to 0. Now what you can do is you can just try to multiply these two first and then try to multiply these two first, right? So this lambda has to be multiplied with both the terms, and similarly this minus 1 has to be multiplied with both the terms, right? And try to simplify and you'll be getting this, and similarly try to multiply these two parentheses and then find out this answer, right? Okay, in this you have to maintain one thing, that your I square value is actually minus 1, so that minus I square value will be equal to plus 1, right? So after finding out, so now you have to multiply these two parentheses. So you'll be getting lambda power 4 minus 1 equal to 0. So what was the Cayley-Hamilton theorem? It states that every square matrix satisfies its own characteristic equation. So what I can do is instead of lambda, I can just substitute the A matrix itself, right? So instead of lambda, I can substitute A. So it will be A power 4 minus and you have this one which is identity matrix, so it is I equal to 0. So I can you need to find out the value of A power 4, so I can bring this minus I to the other side of the equation, so it will be A power 4 is equal to identity matrix I, right? So I can say that the exact answer for this A power 4 will be the identity matrix, so it would be 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So this is the exact answer for the value of A power 4 given in the question. So hope you might have enjoyed this class and you might have understood this, and if you like my video, please do subscribe, review, rate and recommend to your friends, and if you are new to this channel, please do watch our other videos, and for that I'll just attach the link in the description section and go through that once, and then if you have any doubts you can just post it in the comment section. Otherwise we'll just meet up in the next class. Catch you. Bye.